All right, so as you may have noticed yesterday, I had to pick up the new packet, and the packet was all about weather. So we're gonna actually be starting the weather chapter. I do usually teach this in a little bit of a different order, but I do want to just get the weather stuff up and rolling so that when you get to lab, it's not any more confusing than it needs to be. So for today, we're gonna start off by watching the weather report for today. This was this morning. One thing I want you to do while you're watching this is I kind of want you to think of all the weather words you hear while Mike Syka here is talking. So just listen for weather words, things that you hear during a weather report, okay? Yeah, weather is going to be one of them.
Really nice stuff heading our way today, tomorrow, and even much of Thursday. It's not until like later in the day that we're going to start to catch up with some rain showers. But here's the hour-by-hour temperatures today around the metro. And this is probably the biggest issue. We have the natural air conditioner of Lake Erie fired up today. So that's going to keep the immediate waterfront chillier as compared to areas away from the cooling effect of that breeze. In particular, if you're well to the north, well to the east, well to the south, it's going to be warmer. By comparison, though, along the waterfront canal side, Erie Basin Marina, probably going to be in the 40s today. That Lake Erie water temperature right now, 39 degrees. And then we'll build into mid-50s over the banner there at Niagara Falls, also over toward Batavia. And elsewhere across the region, it will probably get up into the low 60s down here across portions of the southern tier into northern sections of PA as well. Look at that, even Albion, pretty close to 60 degrees, well off to the northeast this afternoon. So you can kind of pick your temp out there today. Here's a look at the out-the-door forecast, and the computer is warming us up to around 50 at the airport. I think we're going to hit 50 at the airport, maybe even 51. You know, what's a degree amongst friends, right? Here's a look at the satellite and radar picture. We have a few high clouds streaking in off this warm front to our northwest into the region right now. They're going to push through early this morning, and they're generally toward the thinner side. So even the sun is going to be able to penetrate through these clouds. But I think it gets even sunnier as the day progresses, and we're going to take more of that into the forecast for tomorrow as well. There's those clouds scooting through here early this morning, then it's back to the sunshine. As we work through the overnight, a few more clouds mix in, so becoming partly cloudy, a few cloud patches to begin the day, and then we're back to the sunshine. Perhaps maybe a few more of those clouds down to the Pennsylvania line late in the day. This is trying to squeeze out a few sprinkles late in the day. I'm probably on the fence about that. I don't really think it's going to happen. Wind gusts up to around 30 to 35 miles per hour to begin the day. And even as we get into the afternoon hours today, there is the potential of maybe some gusts close to 30 miles per hour. This is at 4 this afternoon down along the lakeshore. And then gradually that wind will start to settle down for us as we get into the overnight. So, you know what? I think we may actually begin Thursday with a little bit of sun as well. But the clouds definitely will be increasing and thickening as we work through the afternoon. Here's the leading edge of the rain that we were anticipating over the past few days to arrive late in the week. And it's kind of sped up. So we're going to start to catch some of these raindrops in here, perhaps even prior to sunset on Thursday. Much of the rain is going to pass through the area Thursday night. And we'll start the day with some shower activity on Friday. But even that is going to be ending as we work toward the afternoon with the possibility of some breaks in the cloud cover by late in the day. Here's your forecast for today, though. It's going to be milder and a bit breezy, mostly sunny out there. 47 degrees at the harbor front, but along the Pennsylvania border about 63, and all the other spots across the area in between those two values. Mild and breezy tonight, becoming partly cloudy. 41 in the valleys, 49 near the Erie Lakeshore. On Wednesday, 58 near the harbor. The wind's going to shift to the west, so it won't be off the lake directly into the metro during the afternoon. So we should be able to perk up a little bit more because of that. 65 at the Pennsylvania border. Patchy morning clouds, then lots of sun for the day. Maybe a bit more clouds near the PA line late. And on Thursday, increasing clouds in the afternoon, some rain towards sunset, 60 degrees, 50 degrees. Morning rain showers on Friday, ending for the afternoon. Looks pretty nice to start the weekend. And then we get rain showers back in here for Sunday, starting to go over to some wet snowflakes by later in the day with a falling temp during the afternoon.
All right.
My attorney's now at the Barnes firm, settling my job accident case for
800. Shut up. Whoa, but I was singing it too. So what were some of the weather words you heard on there? Yeah. Warm front, weather word.
Region.
Sorry, what was it? Just region, is that what you said? Okay, warm front, region.
Forecast.
Forecast.
Latitude road.
You did?
Yeah. Precipitation.
So I didn't hear erosion, but I wasn't listening for the word erosion since I'm looking for weather words, not weather.
Weathering and erosion.
No, weather words. Chris, give me another word you heard. Oh, I thought you had your hand up. Oh, who else? Who heard some weather words? Sam.
Rain.
Rain. Trenton said precipitation. What else do you hear in there?
Cloudy.
Cloudy.
Wind gusts.
Wind gusts. Thickening, sure. Okay. Not typical weather words that I've heard, but we got, okay.
Raining.
Raining,
Warm.
warm, cold, temperature, wind, pressure. Those are all words you should hear when you're listening to a weather forecast. Those are the things you're looking for. It's the same idea when you ask, like when you're looking and you're like, wonder what the weather's going to be. What words are you talking about? Like when you say, I wonder what the weather's gonna be, what do you wanna know about? Or Phoenix?
Cloudy.
So you wanna know if it's gonna be cloudy. What else do you wanna know? If you say, I wonder what the weather's going to be like today. You wanna know the temperature, if it's hot or cold. You wanna know if it's gonna be windy or cloudy. What are some other things you think about when you hear what's the weather going to be? Thank you.
The rain.
Whether it's gonna be rain, whether it's going to be moist. Oh, perfect. Thank you.
You like the word moist? You like the word moist?
I don't have any feelings towards it. Yeah, I got one more. Okay, overcast, which is talking about the clouds and such. So, if you have taken a glance at your packet, at the top, it actually brings up a couple of these. So we're talking about weather variables. So all those things that you just listed for the most part are weather variables, things that are going to be changing and stuff that we want to know about for the weather. The three main things we're going to be talking about are temperature, air pressure, which he did talk about high pressures and low pressures, and then relative humidity. I'm hoping those three words at least sound familiar. Temperature, air pressure, relative humidity. Do those all at least sound familiar? Like you've heard those words, Phoenix? Have you ever heard those words?
Yeah.
What does any of them mean? How about that? Any ideas?
Temperature means like the temperature.
Okay, means the temperature. That's helpful, but yeah, that is what it means. Anybody know what air pressure or relative humidity is talking about?
Relative humidity is how moist it is.
It is. It's talking about, is it going to be humid or dry out? It gets a little more complicated than that, but you got the gist of it. So, same with air pressure. A lot of people are going to tell me it's the pressure of the air, which you're not wrong. But it does get more complicated than that. We're going to 10th grade it up. So we're going to start right with temperature, which as Phoenix defined, and a bunch of you probably think the same thing, it's the temperature. Duh, what else could you get from it? You're not wrong, but like I said, there's a little more to it. I think you already learned the definition of temperature in 8th grade. We are streaming right now. And some of our peers are going to be watching this today. So we're going to start right on that front page, which, yes, I know it's weird, is page 23. So temperature is officially the measure of the average kinetic energy. In other words, it's how fast the molecules are moving. Now, if you can think back to 8th grade, you learned about two different types of energy, kinetic and potential. So potential is the amount of stored energy. Kinetic is the energy of movement. Do you need to know that for earth science? No, you don't. But I just want to make sure you understand what temperature is. When things are heated up, the molecules start shaking. The hotter it is, the faster they're going to move. The colder it is, the slower they move. Just like when you freeze something, they stop being able to move. All right, everybody got those two bullets? All right. I don't know. I never even used to have a slide for this, but some people didn't know how it was spelled. I'm assuming you all know the instrument used to measure temperature is thermometer. Okay, good. Guys, every single year on the Regents question, there is one question about the instruments used to determine weather. Every once in a while, the answer is thermometer. So a thermometer is the instrument used to measure temperature. And yeah, it is spelled thermometer, which makes sense. It's a meter of the thermo. I don't know what I'm talking about there. It's measured in. I have 3 blank lines. What are the units used to measure temperature? Hint, you did them last night for homework.
Celsius, Fahrenheit, Kelvin.
Celsius, Fahrenheit, and Kelvin. Oops, I didn't go in that order. There is a blank on one side and then a space and a blank on the other. I was thinking you would go degrees F and then Fahrenheit, but it doesn't have to be that way. Just list all 3 of them. Now, I know we talked about Kelvin just for a tiny bit yesterday. Kelvin is what scientists use to measure temperature. In fact, absolute 0 is a measure in Kelvin. It's 0 Kelvin. It's when the molecules are so cold, they stop moving. Notice I did not put a degrees symbol there for Kelvin. Kelvin is not officially measured in degrees Kelvin. It's just measured in Kelvin. If you did put the little degree symbol on the regions, you will not be marked off for that. Sam, did you say what? You don't know. Sam did say what when he said the molecules are so cold they stop moving. You were just being amazed by that fact.
I was
Okay. Okay, we'll go with that. Now these are shown on a weather map. You already saw a weather map up there today. They didn't, I don't think they did it in today's, but have you ever seen a weather map that's coded for temperatures? Do you remember what that's called? It does talk about the gradient. It is when we put isotherms on a map. So hopefully you remember drawing these isotherms, lines that connect places of equal temperature. So that's chapter 2. Remember, connect the dots for slightly older kids. It's making a comeback this chapter. We will be looking at reading and drawing isotherms this chapter. We will review them when we get there, but I do just want to make sure you know they're coming back. All right, and then here was your homework last night. So remember, we had to convert back and forth between Fahrenheit, Celsius, and Kelvin. We went through this yesterday. Can I just have a quick review? Fahrenheit, what do the lines go up by? 2. If you didn't already, I would put a +2 here by Fahrenheit to remind you that the lines go up by 2. How about Celsius and Kelvin? What do they go up by? And again, I would put a +1 up there by the word Celsius and Kelvin, just so you don't forget. Now on the real regions, when you get a brand spanking new one of these, you won't have those labels, but you can add them to your reference table the second you get into the room. Yeah. What was that?
Why is -40 and Fahrenheit?
Isn't that cool? And fun fact, I won $50 for that trivia question once. It was just a random trivia question. And that's because the formula for figuring out Celsius and Fahrenheit, it works out. It's something like multiply by -5/9 or something like that. And it just works out. It's just one random fun fact. And it could win you $50 one day.
Sick.
Yeah, I liked it.
What'd you do with the $50?
I probably filled my gas tank. I don't know. Nothing fun. Get to a point when you're a grown up, nothing fun with $50. Emily, would you like to go to the library where it might be quieter or back to your study hall? Okay, is it quiet there? Okay.
Fill your gas tank with $50?
It was several years ago that I won, so it was probably cheaper. I still needed a babysitter for my kids, so it was way before COVID, so prices were cheaper. So this was your homework. You're supposed to be checking it, by the way. Would you like me to read it off? Would it be easier to see or hear?
Yeah, 150 or not, I have 160 for 158 spot.
Okay, then you did it wrong. We even did that one together. So that, starting with that first one, it should be 158 Fahrenheit and 343 Kelvin. Then down one is 8 and -13.
8, 9.
Okay, so
Six
if
are
you
too
did
small.
4, you counted by ones, so that's why that one was wrong.
They're too small.
They are small.
You don't have a blown up version of this thing?
I do not. Would you guys like me to get you a blown up version of this page?
Yeah. that would be
Okay.
easy.
The only dilemma I will have with that is then you won't have it for the region, so you do have to get used to this. So here, why don't you guys keep checking your work there? I actually might already have blown up copies of this.
You know about some?
Yeah.
No, I don't have blown up copies yet, but I'll get them for you guys for tomorrow.
So the decimal ones?
Yeah, the decimal ones you guys don't have to do. You can go. So this one would have been 24, and that would have been 233. This one would be 28. Okay. Are there any that you were way off? So we already talked about, so Drake said he had 4 here where this one was 8. I know for a fact that he's then counted by ones in that case, so make sure on the Fahrenheit side, you're counting by 2s. Yeah, Trenton, which one?
75 degrees Fahrenheit. I got 35 Celsius and 308 Celsius.
So let's pull it up. Yeah, I could have been wrong. So I'm sorry, which ones was it? The 75 Fahrenheit.
I got 35 Celsius and 308.
Okay, so one thing, like I mentioned yesterday, is I do like to put a Post-it note. It was 75, right? Okay, so there's 70, 72, 74, there's 76. I just want to go down a little bit. 21. I can't even see either. 21, 22, 23, 24. And what did I have on there? 21, 22, 23. I would say I have probably 24 here now. Whoops. Okay, so I said 24, 23.9. What did you have? Whoa. Well, you definitely did that one. Like way wrong. I don't even know. Yeah, that was just wrong. But it's okay. One wrong means you made one mistake. If you do 30 of them and you make one mistake, that's probably okay. Let's move on to the,
This is what
yeah.
Remy said.
Okay, good to know. Hope he's okay. Okay, well, I hope he gets better. Here's the other chart. So I know yesterday we just rounded this up to 99. Any major issues with this one?
Yeah, I got 99.
For Fahrenheit, for water freezes, I said 0.
Well, that's wrong. Water freezes 0 Celsius, not 0 Fahrenheit.
Whoops.
Yeah, so did you do that on the top of your head?
Yep.
Yeah, see, this is where our head is not, and I know I've said this multiple times before. Please don't trust your brains. Our brains are not trustworthy because,
I don't have one.
well, there's that. Your brain, you guys have a lot going on. I highly doubt you're ever focusing 100% on earth science. I know I'm not. I'm trying to remember like a gazillion million things in my head, and I'm trying to teach it to you, and I know I'm not focusing. I highly doubt you guys are focusing 100% on earth science.
Earth science summer class before.
Okay, so my point is just look up the answers in the reference table. Please don't trust your brain. Use your brain for the classes that make you use your brain. This class, you get to look up answers. What's up, Phoenix?
Why do other countries use Celsius?
So because it honestly is easier, because don't you remember 0 and 100 better than you can remember 32 and 212?
Yeah, but that's remember the thing with like pounds and
It is exactly like that.
pounds is way easier.
You think pounds is way easier than even though those go up by hundreds?
Yeah. It's way
Yeah, so I think the only reason you think it's easier is because you're used to it.
45 pounds is like 23.2
Yeah, do you think they use 45-pound plates in other countries? They probably use,
No,
It's like
kilograms.
kilos and
yeah, they use 10
Yeah,
kilos,
it's
20.
like they have like points at the end, that's weird.
Yeah, but it's actually an easier number because it's a base 10, which means everything always goes by 10. Like there are 10 centimeter, or there's 10 millimeters in 1 centimeter, or 100 centimeters in 1 meter. It may, instead of saying there's 3 something inches in, or centimeters in inch, whatever, it's way 12, that's it. 12 inches in a foot. It's not as easy to count by 12s as it is to count by 10s.
I also-
But not the point, you did it again, Phoenix. Why do I let you talk? Got me behind schedule, but why do we not use it? Because we're Americans and we're stubborn,
I don't
to be
like-
perfectly honest.
I
Good to know. Don't go there then. All right. One more thing. The bottom of this page says heating and cooling of air by expansion and compression. We already learned this. What does warm air do?
bam.
Okay, where does warm air go? Up. Warm air rises. What does it do when it's, or your feet are, oh my God.
Expand.
Trenton already mentioned it expands. Remember, hot molecules, what do? They spread out, just like hot, sweaty humans. Hot, sweaty humans spread out because you don't want to be cuddling next to a hot, sweaty human. Don't argue with me. Yes, they do expand.
So wouldn't it be more accurate to put that in like the middle of the room, like the middle line, like that thing right there?
The thermometer.
It's really, it's kind of like at the top.
You're right. Yes, it is. Imagine, it's not quite, it's about it's your height, head height,
You just call yourself.
shorter than Phoenix. All right, here's what you need to put in your notes at the bottom. So it does say, what space do you have there? So heating and cooling by expansion. Right here, when a gas expands, its temperature decreases. Yeah, so those hot, sweaty molecules, what do when they spread out? If you are a hot, sweaty human and you spread apart from the other hot, sweaty humans you were next to, what's gonna happen to your temperature?
Cool down.
You're gonna cool down. So when those hot, sweaty molecules spread out, they will cool down. What?
Doesn't the air circulate where it goes?
Yep, that's what's going, that's what we're talking about right here, dude. So when warm air rises, it expands and then its temperature will decrease. So absolutely nothing we just talked about today is new to you. Every single thing that is on this first page of notes is review. The only new thing was learning how to go back and forth using the reference table, but you guys clearly established that wasn't that difficult. If you only want to get this first bullet, that's fine, because the second bullet's just the exact opposite. So when we push molecules together, just like when you're cold and you huddle together, what's going to happen to your body temperature? It's going to get warmer. So when you compress things, they get warmer, and when they expand, they get colder.
How do your hands get warm for like if you drop them?
That's friction. That's something different. So. All right, I just want to do 1 or 2 more things on the pressure side. So again, as long as you get that first bullet, the first half of this, when warm air rises, it expands and its temperature decreases. Alrighty. Pressure. Air pressure. If I asked you to tell a kindergartner what pressure is, what would you tell them? So you're gonna squeeze something. So that's you putting pressure on someone. So if you're gonna squeeze their brains out, you're putting pressure on their brain. I know I'm horrible. What's air pressure then?
That for air.
Pressure on the air from the air.
It's pressure from the air. It's the pressure the air is putting on us by just pushing down on us, or in your tire. If you need pounds per square inch in your tire, it's the amount of air pushing out on the tire. So you keep putting more air in and it's pushing out. Yeah, Trenton first.
Like,
I don't know it in pounds per square inch. We can Google it. What's up?
does that involve like gravity?
It does involve gravity. So gravity is pulling the air towards Earth. So officially on the top of the page, what is that, page 25? Please give me these two bullets on the top of page 25. Air pressure is the weight of the Earth's atmosphere. It does change depending on temperature. Because remember, warm air rises, cold air sinks. So if it's cold, more air is going to be pushing down on us. If it's warm, more air is going to be like lifted off of us. What is it? That, oh, I knew that. Why? Darn it, I knew that because my next sentence was going to be, do you feel the air on you right now?
Talk about this.
We did. Yeah. So you should feel the air pushing down on you right now, but you guys are used to it every day. Yes, you are underneath a cold breeze. But guys, on every square inch of your body, there is 14.7 pounds of air pushing down on you. There is. Even on every, so every square inch of your body has 14.7 pounds of air pushing down on you. So you're pretty strong, even if you're just lifting air. So Phoenix, I mean, imagine how much you're benching or squatting when you're taking into consideration the air.
So that's like 30.
Yeah, we'll go with that. All right. We do have an instrument used to measure this. I'm not sure if anybody's familiar with a barometer. Maybe you've at least heard the word. But you will need to know this, just like you know a temperature, or a temperature is measured with thermometers. Air pressure is measured with a barometer, or in this case, a barometer. There are 2 units of measurement used in science. There are more, like Trenton brought up, pounds per square inch. But in science, we're either going to use inches of mercury or millibars. And on a weather map, these, again, we went over this in chapter 2, just a quick review here. On a weather map, these are going to show up as isobars. So you can hear that barometer, barometer, isobars, millibars. These are lines that connect places of equal barometric pressure. By the way, barometric pressure is the same thing as air pressure. Yeah, stronger than you look, huh?
Average human body has about 2,635 square inches.
That would be, you'd have to be laying flat because your square inches will change. How much air is pushing on you will change depending on how you're laying.
Average, it's like 2,635.005. Multiply that by 7, you get 38,734 pounds in total. Dang.
So guys, this is a makeshift barometer here. This is where inches of mercury come from. So this is a bowl filled with mercury. And if you don't know, mercury is a metal that's liquid at room temperature. Yes, it can cause brain damage. So don't touch it, don't lick it, don't eat it.
Why just metal?
No, but it's just, so is lead. Lead is just a metal. It causes brain damage.
We've never drinking it before.
You could get mercury poisoning and you could become crazy. Ever heard of the Mad Hatter?
Yeah.
He was mad, meaning not mad like angry mad. He was mad like crazy because people who used to make hats used mercury. Why? I don't know, but they did. That's why he was crazy. But back to this.
And lip gloss, too.
Back to this, we've got a test tube with labeled in inches. When the air pushes down on this bowl of mercury, where's the mercury gonna go? Up the test tube. That's where inches of mercury come from. So when the air is heavy and pushing down, the mercury is going to go up. When does air go down? When the pressure's high. Okay, but when does air go down? We already talked about it once today. When it's cold. Cold air sinks. So on a cold day, the air is going to be sinking, which will cause the pressure to go up.
So then why does the thermometer raise?
Because that's because in that case, it's not, that wasn't a barometer. A thermometer works different because when it's warm, it expands. This goes in the barometer spot, and then we're just about done. So a barometer, as the air pressure pushes on the surface of the mercury in the dish, the mercury travels up the tube. Cold air sinks, meaning we have high pressure. The mercury is rising. Warm air rises equals lower pressure, and the mercury is sinks. So get those 3 bullets word for word. I know it's a little bit of writing. One last thing after this, grab your reference table. You need to be able to do this last thing to do your homework tonight.
What page?
13 still. All right, so grab your reference table. We, just like with temperature, you will be asked to switch back and forth between the 2 different units of measurement. So we're still right here on page 13. So yesterday your homework was here with temperature. Today your homework's going to be here with pressure. These conversion sheets work exactly the same way as the temperature one did. So tonight's homework are going to be these 2 charts again. And you need to go from inches of mercury to millibars or millibars to inches. So let's do one of these together. Let's start with the inches of 29.06. Let's see if you can find that. Where's 29.06? Right there. Thanks, guys. That's super helpful. It is down there. Yeah. Here's 29 right here. There's 29.10. So where's 29.06?
Down 4.
Okay, so there's 29. What are the little lines going up by? If you did not notice, they're going up by 0.01. So there's 29, 29.01, 02, 03, 04, 05. 29.06 is right there. I'm going to go this way, 29.06. Now, what is that in the millibars side? Yeah, is it right on the 984? No, we're a teeny tiny bit above it. How much above it? Not very far. If that's 2985, I'd say 29.842 maybe. So 984.1 or 0.2. So again, we're right here. Where are we? Sorry, right there, right above the 984, but not up to the 985. So just like yesterday, I do recommend writing the labels that these go up by 0.01. What does the other side go up by? Those sides just go up by 1. So that is your homework, just these 2 charts, nothing else. Don't worry about the graph on the bottom. You guys can keep working on that while I pass back your test.